Okay, people, let's get started. Today, I want to talk about who caused the climate problem, where the responsibility lies, and who's benefited the most from fossil emissions, and what's a fair way to assign responsibility. I'm going to be taking this through the lens of a natural scientist and data person, not from an ethical lens. But you will see that almost everything I have to say today has strong ethical implications. All right, so we all know that the current emissions profile now, this is over the last decade for which we have complete data. 86% of it came from fossil, 14% of it came from deforestation. The problem is primarily fossil emissions. We know all of that. We know that only 44% ends up in the atmosphere, and we know why. The rest gets taken up by the oceans, and the fact that that uptake by the oceans and the terrestrial biosphere is likely to be long-lived, but diminishing as a fraction through time. The more we emit, the faster the sinks diminish as a fraction of the total emission. But the absolute magnitude of those sinks continues to climb, because to a significant extent, they're just driven by Le Chatelier's principle, which says, you know, the more there's on the one side of the equation, the faster the reaction goes. Okay, so although the problem, you can see from this, currently is almost entirely industrial. It's industrialized activity that does the game. There are countries for which land use still is the dominant source of emission, and I just want to point this out. All right, so when we talk about climate mitigation as being something that hits the industrialization of poor countries, also be aware that for countries like Indonesia and for countries like Brazil, they have emissions profiles that are dominated by land use, by the expansion primarily of agricultural activity into pristine tropical forests to a certain extent. And of course, this used to be true of every nation. It was true before the Industrial Revolution in every nation, right? And it's only in the 20th century, even in industrialized nations, and most of them, that industrial emissions of CO2 surpassed land use emissions. Okay, so the global concentration of CO2 in this figure has gone to about 410 ppm. Number's more like 412, 413 today. This one is running through, I think that's 2020 here. And these little wiggles are the biosphere waking up in the northern hemisphere and then going to sleep again in the southern hemisphere, so whether or not photosynthesis or decomposition dominates the terrestrial biosphere. It's the northern hemisphere because there's a lot more land in the northern hemisphere than the southern hemisphere, and so it dominates the global picture, and CO2 is well mixed. And so that wiggle is the strong action by the biosphere, which is one of the reasons you're worried about biosphere feedbacks, like remember that fridge door feedback? It's because you look at this biological activity and the slope that it's able to generate on the atmospheric CO2 is so much larger than the slow, steady growth from anthropogenic emissions. And that's simply because in absolute magnitude at any one time, the fluxes from the terrestrial biosphere are much larger in magnitude than the fluxes from industrial activity. But nonetheless, that's the culprit. And this is the emissions profile per annum for the entire world. And you can see here that the last data for which we have a complete year is 2020, and you can see this big COVID-related drop, okay? That's the COVID pandemic. But you can see even before the COVID pandemic that this thing was showing signs of wanting to level. You see that? I mean, this thing was climbing really rapidly here. And although you think about the growth of CO2 as being relentlessly upward, the emissions per year as being relentlessly upward, it kind of stabilized here for a while. And then those 2 years are about the same, 2018, 2019. And then we get this big drop in 2020, and it's going to be down again in 2021. It will recover post-COVID, but it's very clear that this pattern isn't climbing ever upward the way it would be in one of those extreme business as usual scenarios that we used to call a business as usual scenario. And of course, there are reasons for this. The reasons are overwhelmingly technological change, not deliberate mitigation yet. It's technological change. On the other hand, the line between deliberate mitigation and technological change is extraordinarily fuzzy. Why is it that wind and solar are the cheapest forms of electricity now so that they dominate new installations? The reason is that the nations of the world subsidized them for decades and created markets that relentlessly drove their price down. So when you say this isn't deliberate mitigation, yeah, it's not countries getting together with a treaty and deciding to emit less. But it is, to a very real extent, the result of policies in the past that deliberately targeted alternatives to fossil fuel, and for a long time. And collectively, not just in the United States, not just in Europe, but almost everywhere. And so this is an interesting pattern, and we'll see where it goes. You can break that down still further, of course. If you break it down by country, what you see is that the emissions in the United States, for instance, peaked around 2001, 2002, and then started to drift down. You see that? It's a long, steady, slow drift down. And then there's this COVID drop. Europe peaked quite early. They've been drifting down for a long time. You see that? China was climbing, but you can see there starts to be a marked deceleration here. Maybe that's short-lived, but all of a sudden, I'm sorry, that's the world. China had this marked deceleration in past years. There's a few that rose, but there was this real boost period that then stabilized to a significant extent. India was looking concave up, and most business as usual curves, but it started to reached an inflection point, started to curve down. So nations of the world are actually showing slowing growth in emissions or declining declining per annum emissions, even prior to COVID. And so we're going to figure out why. And now, the problem is, of course, that this isn't enough to stabilize the climate. Remember, the whole point about CO2 being long-lived in the atmosphere is that if you want to stop the growth of CO2 in the atmosphere, emissions have to drop effectively to zero, or very close to it. They have to drop so low that the sinks balance the sources. So it's not enough just to cut emissions a bit to stabilize them, none of that. It'll just keep climbing and climbing and climbing the way it would if you turned water on in a bathtub without a drain, right? Just, you gotta stop putting the water in if you don't want the level in the bathtub to go up. But nonetheless, this is a sign that even when I started this class, wasn't nearly as apparent in the data, all right? So this is the result of big changes. Cost of wind and solar has been halving approximately every 3 years. You go 3 years back, and it was twice as expensive as the alternatives, not just a little bit cheaper. You look at what fuels are fueling this drop. Well, globally, it's coal. This doesn't have a breakdown for the COVID signal, but emissions from coal dominate oil, gas, and cement, but emissions from coal all of a sudden slowed way down. You probably noticed in the news that China announced, I think last month or maybe 3 weeks ago, that they were not going to build any more coal plants. And they weren't going to market any more coal plants to anyone else. All right. These are annual fossil CO2 emissions just in the United States. And you can see that coal has been going extinct for a long time due to market forces. Why is coal going extinct? Well, it's going extinct for two reasons. The first was the shale gas revolution that made natural gas cheap and abundant, all right? And now, the primary reason is that wind and solar are so much cheaper than new coal installations. It's cheaper to install new wind and solar than it is to run an old coal plant, okay? So that's the problem. The idea that you could take regulations away and coal would be saved is crazy. You take regulations away, regulations are currently helping coal stay alive, all right? That thing is headed towards zero and quickly. All right. And you can see, though, that emissions of oil and gas in the United States are, well, emissions from oil are, there's no real upward trend. It hasn't been for a long time. And with the electrification of the vehicle fleet coming, this number is going to just crash. This is almost all transport. And natural gas is still climbing. These are the European Union's data. You'll see that it looks pretty similar. Coal has been declining for a longer period of time. That's because gas came in from Russia in pipelines and also from the Middle East and Central Asia. But otherwise, the picture is pretty similar. They've got a longer and more obvious decline in oil, and that's primarily because of increased emissions. Increased taxes on motor fuels. There are taxes on petrol in the European Union and the UK would be the equivalent of about $1,400 per ton of CO2 when the European carbon price is about $20 per ton. So they get a lot of the revenue for government from fuels taxes. This has driven much higher fuel efficiency and decreased oil use. Emissions in India, the big player coming on the scene now. Most of it has been coal because of domestic availability of coal production. But even before COVID, it leveled off here. You could trace that down, what happened. They have coal quotas, all right? Modi's government is tightly aligned with railroads that ship coal and want to have coal contracts, and also with coal producers, but the railroads have a big thing to say about it. They missed their quota. They missed their quota because everybody in big part, particularly of northeastern India, installed solar instead, all right? It was just cheaper. So that's what's going on there. Oil's still drifting up. India is a country climbing out of poverty, and the accoutrements of the good life do tend to consume fossil energy. You look at the rest of the world, and I'm not really sure what this is showing. It's kind of like India, but with more gas, because India doesn't have a lot of natural gas. There may be a field off the southern coast of India, actually both sides of the southern coast, but those are still under development. It'd probably be a good thing for the world if they found some that was marketable, but some would disagree with me there. So anyway, so who does or did the emitting that caused the problem? And here we get into ways to analyze the data that have ethical implications. And I'm going to look first at 4 different ways. The national emissions. So who's responsible? Under the UNFCCC, the United Nations Framework Convention for Climate Change that sort of dominates the international law in this area, nations are the responsible entities. But when you think about what does a national responsibility mean, all right, well, that's one of the things I want to explore. National emissions per capita, because after all, people are the responsible agents, so maybe it's per person. So do you get off the hook because your national emissions are small because you're a tiny country, you know, Liechtenstein? National emissions per unit of GDP, or in other words, how much does it take to generate a unit of economic activity? And then we could also look at cumulative national emissions. What's the sort of historical legacy? Who, in fact, filled up the atmosphere with CO2? And the pictures for these give you different answers. So annual fossil emissions, if you look at the top 6 emitters currently, China is in the lead by at least a factor, by now, close to a factor of 2. That's a big deal. So China is twice as bad as the next player, and the next big player is the United States. There are some other nations that are in there ahead of us, but they're small nations primarily. I think Australia and Canada are both a little ahead of us. You got to drive long distances there. The EU is in next place. India is pushing up against the EU. Russia, even with a small population, is surprisingly large, bigger than Japan. Okay. Annual fossil emissions per capita. The US is #1 here, again, among big nations. And China is all the way down here, right? So China has an enormous population, and that's the deal. The amount that they're actually emitting per person is significantly beneath the United States and on line with what it is in the EU, all right? Just about. Sort of tied with the EU right now. Underneath Japan, underneath Russia, India's way down here, and the US is still up there. Think about 16.1 tons of CO2 per person in the United States. Think about what 16.1 tons looks like. So that's 32,000, well, more than that, 35,000 pounds, because these are metric tons. So think about 10 Cadillacs laying in your backyard. All right, that's the amount of CO2 that the average American puts into the atmosphere. It's a gigantic amount of material. In terms of the material that you handle in your lifetime, like 35 tons worth of stuff. There isn't 35 tons worth of stuff in any other aspect of your life, if you think about it. So the amount of CO2 we're emitting for the lifestyle that we have weighs more than all the other stuff you've got put together, unless you went out and bought a semi or something, right? I don't know. So some of you may have something really heavy in your portfolio. But I mean, you have to own a yacht or a house or something, I suppose. Most of you don't yet. Okay, annual fossil CO2 emissions per unit GDP are here. China is quite high. The EU is way down. The USA is here. This was a favorite measure of economists until recently. And it was as though they thought that the economy was a machine that turned energy and the fossil emissions that generate most of the energy into money. And it turns out that's just BS. Doesn't happen. The economies of all these countries that have declining emissions, like the United States and Europe, continue to grow as the emissions shrink, okay? The economy is not a machine that turns emissions into money, except maybe at the very beginning, when you're building the infrastructure necessary for an economically expansive life. So it takes a lot of concrete to build all the high-speed railroads in China and all the high-rise apartment buildings that are now surrounding all of these cities. Once you've paid that down, the pace of building goes way down. China was using most of the world's cement for a long time. The cement releases CO2, so there's sort of an infrastructure build payment. But aside from that, there really doesn't appear to be a very strong connection at all between economic growth and emissions. And so you ought to just think about them. The better assumption that they're perfectly coupled is that they're independent of one another, okay? They were coupled until the Arab oil embargo in the 1970s. And then they became decoupled, and now they're just, looks like they're close to independent of one another. Forget that one. This is an extremely interesting and important graph. One of the things that people like to say is that China's emissions are so high relative to the US's, not because of China, but because of the consumption in the US and other places that have offshored their manufacturing emissions to China. And we're the ones that are consuming the products that are actually causing those emissions. Under United Nations Framework Convention rules, the emissions belong to the country that they're emitted in, no matter where the products that led to those emissions are destined to reside in the end. You don't look at the emissions embedded in products. But nonetheless, you could. And this is an attempt to do so. It's a graph that separates. The solid lines are what the emissions are that are actually emitted in your country. And the dashed lines include all the emissions embedded in the products you import, minus the emissions in the products you export, okay? So that's the trade emissions that we were talking about. How much is actually offshored? And you can see that China actually would have less emissions internally if you included all those that it's exporting to others that are actually creating the economic activity and realizing a lot of the benefit of those emissions by using the products that China's creating. But it's kind of small potatoes, even in China. You see here? This is a less than 10% bump. It's a second-order term. In the United States, it's teeny-weeny. EU, India. Bottom line is, this is said all the time. You'll find it on all kinds of websites whose opinions you'll agree with, but it's just not true, okay? It's just not true. Data doesn't support it. The end, okay? This is false. But it's true on the margin, and for some countries, it's a huge difference between consumption and territorial emissions. And what are those countries? Tiny little landlocked countries, primarily, that have to import just about everything, okay? Those countries have consumption, but they're not the countries that you're thinking about. They aren't the big players in the emissions story. They're little landlocked countries, particularly poor ones, okay? All right. If you look at cumulative historical emissions, the thickness of the band represents cumulative historical emissions in a particular year. So early on, Europe had the Industrial Revolution first, and it dominated, the UK in particular, fueled by coal, 1850. Now, the US has the largest historical emissions of any country. The EU, which of course is a conglomeration of many others, is substantially smaller. But China is going to pass the US in cumulative historical emissions in another decade or so. So the United Kingdom now, which had dominated the picture, was responsible for more than 60% of emissions 170 years ago, is now just a bit player in the cumulative historical emissions. And this is a measure that carries with it some semblance of a sense of responsibility, right? Because the cumulative emissions, to a significant extent, will correlate with how much wealth you've accumulated inside your economy. As I said just a minute ago, emissions and income growth, economic activity, seem to be decoupled now, but they weren't prior to the Arab embargo on oil in the world. Then there was a lockstep connection. And so, to some significant extent, every dollar in the world depends on the Industrial Revolution, and so has robber baron roots. And so you can look at cumulative emissions, especially if they happened prior to 1970, prior to 50 years ago, and think about those as being the same as national wealth, the fraction of national wealth that was seeded prior to that period. All right. Finally, if we look at OECD countries, the developed countries versus the developing countries, emissions are now larger in the developing world. We'd like to say that this is a problem of rich countries, but it's really not anymore, all right? Non-OECD countries are responsible for more emissions, almost double the emissions that OECD countries are. And China is, of course, leading this pack, but there are many others as well contributing to it. This is just a graph that I wanted to point out. You have energy consumption per capita on the vertical axis and GDP per capita on the horizontal axis. And these data obscure a lot of distributional heterogeneity within each country. But the thing I want you to notice is that each one of these is a log scale, okay? And that means that if this thing curves at all, it really is a big deal, all right? Because there are logs that are changing. And the pattern is one that, when these data were collected by the World Bank, was already bending over. That bending over has really accelerated as emissions have dropped in the richest countries. And so the point here is that there appears to be some sort of a sigmoidal character to these data now, and they're dropping on the other side. And the numbers that we're talking about, where you start to drop, is at about $10,000 per person of GDP, per capita GDP of around $10,000. That's the threshold where all of a sudden the growth that comes from climbing out of poverty appears to be dissipating. Why is that? Well, until you get really rich and you buy like a jetliner, there's only so much stuff you can buy that emits, okay? And so a person that has 100 times your wealth doesn't have a house that's 100 times the size of the house of a person with 100 times less wealth. It might be double the size. It might even be 5 times the size, but it's not 100 times the size. So it doesn't cost 100 times more to heat and so on. So people get stuff, and then they kind of get saturated with stuff until they get a whole lot of money and they can buy a jet plane if they want to buy a jet plane, and that really starts to, but not many people have their own private aircraft. You can also look at this this way. This is cumulative emissions. So what happens is the bars add on top of one another. And what we do is we take the way a graph like this is put together is you take the country in the world with the smallest emissions, and then you find out how many people it are, and you put a dot there for that country. And then you add that little bar to the second smallest cumulative emission, the second smallest emission. And so this is graphing the sum of all the emissions to the left, okay? And so what does this show? This shows that most of the world, the 1 billion people at the bottom, are emitting nothing, okay? Just nothing. There's no, it doesn't build up, just nothing there. Cumulative emissions are all done by these characters, by these nations out here that are wealthy. So the poorest nations of the world are actually emitting nothing. The bottom billion just isn't emitting anything. And this is the first harbinger of the falseness of the dichotomy between poverty eradication and emissions control. I often even say that countries ought to be able to emit because they need to climb out of poverty. It's true. But what I don't say is that, and if you let them, it's not going to do anything to emissions to a first approximation because they aren't emitting anything now, right? So we'll look at that more in a bit. But poor people aren't responsible for this. So let's consider the principle or concept of fairness that would justify a difference between commitments of developed and developing nations. What quantities should be used to set a nation's nationally determined contribution to climate mitigation under the United Nations Framework Convention? We're going to have a new treaty. We're going to be adding, country's going to have new national commitments. Biden administration plans a really stringent one. So what should be the thing that sets the number, all right? What principle, concept of fairness would justify? So let's first of all just ask what quantities should be used, and we're going to vote on the nation's population size, the nation's historical emissions in addition to its current emissions, the nation's current GDP. Should that matter? nation's total wealth independent of its current GDP. How much money does it have banked? And the nation's infrastructure assets. So I'd like you to vote. We'll do them one at a time. And we'll start, let's see, with a nation's population size. Here we go. Okay. I think we can see the results in real time. There is no C. Okay. All right. That's probably enough. You're going to have plenty of time to vote. So if you haven't clicked yet, that's no big deal. It's sort of, 60-40 for yes and no. The reason for yes matters, right? I mean, it's pretty obvious if there are more people doing the emissions, right? So shouldn't the commitment of China be bigger than Zambia? Or let's take a nation that has comparable GDP per capita to China that's tiny. That might be, well, no, not Venezuela anymore. Trying to think of a nation that has almost exactly, Mexico is a little bit richer than China. Let's make it Honduras, maybe. Honduras stays close. So obviously China needs to do more than Honduras, right? I mean, it has to. But some might argue that, so who wants to argue that population size is irrelevant? Does anybody? And be brave if you actually think it is. Yeah, in the back. Yeah. Okay. So population size. So what you're arguing is per capita emissions matter, but population size per se doesn't matter once you've per capitized, if that's a word, emissions, right? And that's actually a good point, right? So all right, we'll kill this one. Now we're going to go to the next one, which was the next one. So what do I do to get rid of? On the cloud again, okay. All right, the next one is a nation's historical emissions in addition, whoopsie, that's not doing it again, huh? Huh? Results again? There we go. All right, so we're going to do historical emissions. So you can see this is going overwhelmingly yes. Historical emissions should matter, okay? And somebody who's voted no in the minority, can somebody explain the reasoning for the no's? Yeah.
I think like at the moment, you should focus on
Yeah, that's a pragmatic argument, is that you want to do a negotiation, and so another way to say the same thing. Let me put it in slightly different terms. My people are immigrants to the United States. When they signed the papers, did they assume the legacy of past emissions? Was that all of a sudden their responsibility? All right, and if so, why? Right. So that's kind of. It's in some sense the same argument. The negotiators, you could say they're responsible for it, but they didn't do it. All right. And then in addition, pragmatically, if you want to solve the thing, it's about stopping it now. Somebody else wanted to say something, I think? Okay, we can move to the next one. Nation's current GDP is going to be the next one. Current GDP. Yeah, so rich nations have more responsibility than poor nations, and I think the answer to that one is pretty obvious, right? At some level, nations deserve the right to give people the infrastructure that is consistent with the lives that most people around the world aspire to. Not everybody, but most. And so I think that reflects the overwhelming yeses there. And nations' wealth, total wealth, independent of current GDP. Well, let's just do let's move on. I don't want to belabor this. You can think about that. Total wealth independent of current GDP. It's not just how much you're making, it's how rich you are, right? The richness is, in a sense, a legacy of past GDP, right? And so it's accumulated activity that is, prolonged high GDP means high wealth. And nations' infrastructure assets, we've already kind of talked about that when we talked about the current GDP. So this is a graph that UNEP produced in 2017 that's been really influential. And what it says is this is a trajectory at the time that was consistent with net zero greenhouse gas emissions in just before 2090. And this was a scenario that got us under 2 degrees, not by a lot, but under 2 degrees. Now, of course, the overwhelming political momentum is behind a target of 1.5. So it's more stringent than this, where you have to get the net zero in 2050. The blue are negative emissions. Those are sinks that are artificially created. The brown, light brown, is CO2. The darker brown are other greenhouse gases. But the point is that even with this trajectory, if you do the analysis, most analysts come to the proposition that to get here before 2090 globally, developed nations would have to drop to net zero by 2050 to give developing nations a little bit more time to emit as they build the infrastructure that climbs them up into the kind of living standards that developed nations enjoy. So that in our country here, whether or not you're shooting for 2 degrees or 1.5, you've got to quit by 2050. The real difference between those two targets is is the pace of change required in the developing nations. All right, I want to go through just an exercise, and I'll do this relatively quickly. It's an exercise that a bunch of us developed around here, and it's still the only thing like it that's ever been published. This thing is old now. It was published in 2009, so it's a dozen years old, which by scientific standards is ancient. But it just goes to show you that if we wanted to as a species, we could assign responsibility in another way. We've been talking on and on and on about responsibility, and we've been talking about a nation's responsibility. And if you think about it, what is the concept of national responsibility? Where does it come from, and what does it mean? To what extent is a nation the responsible entity? Any one of you, if I ask, well, what underpins your personal responsibility? You'll have lots to say about it, and you've thought about it all the time. And when we hear the words national responsibility, it sort of sounds okay, and we don't question, but if you actually think, well, what is a nation's responsibility? Again, if I take let's suppose that the dreamers, all of a sudden we finally decide there's a road to citizenship, and the dreamers all become citizens. The moment they become citizens, do they have the responsibility for everything that the United States has ever done? Do they assume that in some sense, right? Is it their responsibility now? And so if not, then what is it that actually shapes national responsibility? And so just as an exercise, because And well, I should say, you can talk about it if you're in the ethics portion of the class, about what national responsibility means. There are clearly some parts, some aspects of responsibility that do reside in nations, all right? Mostly having to do with aggression and warfare and stuff like that. But everyone's comfortable with personal responsibility, notions of personal responsibility. And so we decided to try to disaggregate nations into people and look at every person's emissions within a country, to disaggregate the emissions to the individuals within it, and then to try to set up national targets based on who was using more than their share, all right, in the country, all right? So to establish a national target by simply aggregating individual targets. So this is what we did. The first thing we did was we constructed two different ways we lined up everybody in the world. And the data we had at that time, there were only 6.25 billion people in the world, something like that. And we lined them up from the least emitter to the biggest emitter, all right, in the entire world. And then we said, all right, let's then take the emissions of the least emitter, and we'll add it to the emissions of the second emitter, and then add it to the emissions of the third emitter, and so on. And this is a cumulative emissions curve, okay? That's what that thing is going to be. And we'll use that in a minute. There are two different ways to do this. We actually did it at a national level. And then we disaggregated the people at a national level, lined up the people in the United States. And we also did it for China and every country of the world. And then we did it from sort of bottom-up activity, how much stuff they own, how much, what their energy emissions are in a bottom-up way. And we also did it from the top down, from aggregated national emissions and distributions of income and stuff like that, and came up with the same answer. All right, so this is what it looked like. And this is the cumulative emissions curve. And so by the time you get to the piggiest person in the world, that person is up here. And you can see this slope is going way up here. And the interesting thing here is that if you divided humanity at that time into two, the median, the bottom half, which is the bottom 3.3 billion people, were responsible for only 70% of the, or 7% of the total emissions. So the whole bottom half was just responsible for nothing. And that's because they didn't own an air conditioner, and they didn't own a car, and they didn't own anything to do the emissions. And beyond that, almost the entire problem was caused by the top 10%. And these aren't the top 10 richest nations. These are the top 10 richest people, primarily. Top 10% richest people were responsible for half the total problem, all right? Now, this had a number of implications. First of all, but I'm sure this is still the same. If we did it today, I'm sure you get exactly the same freaking answer, okay? Somebody ought to do it, but it turns out it's a real pain in the neck to do this, which I think is why nobody's done this. You could bring everybody at that time, all 3.8 billion people, up to the median level of emissions, to the average person. And it's such a small increase in emissions, because they don't emit anything, that I wouldn't be able to see that. So we could take the bottom half of humanity and bring them up to the current average for emissions. They'd be they'd be wealthier, and they'd emit, but the effect on global emissions would be so small that it would take me 10 years of data to even see the signal in the atmosphere. All right, it's tiny little perturbation. Whereas if I cut the emissions of the top 10%, it'd really have a big impact. All right. And again, these are not just wealthy people in wealthy nations. These are wealthy people also in poor nations. At the time, one of the people who was sort of famously traveling around doing this was a Bolivian environment minister who went to a climate treaty and said famously, "You and the rich nations have eaten the atmospheric pie, and or atmospheric pizza, and you've left us the crust in our nations." And she flew there in a private jet, okay? And so This is not to run down Bolivia, but this is a problem of wealthy, high-emitting people everywhere. Disproportionately, it's true in wealthy countries, but high-emitting people everywhere. And where you reside, I don't know, I'd be curious to know the ethical underpinnings of a decision that where you reside gets you off the hook somehow, right? All right, so who are these people? You can look at, and not just the cumulative emissions, but the cumulative earnings, and the curves are almost the same. So the top 10 highest emitting people are the top 10% richest people also. This is just a little exercise. Nobody's ever really taken this seriously. But you could imagine that we could build a national system in which we do this in every country. We line people up from the lowest emitter to the highest emitter. And then we globally say, OK, in this year, to get on track to net zero, there has to be a cap on per capita emissions. And so this is the individual emissions cap. If everybody were under that, given all the data, the world is going to be on target to get to net zero. That cap's eventually going to go to nothing, right? And you could take the amount that a country is over by looking at the individuals who are over and set the national cap as the sum of the reds, all right? The sum of the overages. And so you could aggregate up a national emissions cuts from the overages of the individuals in that nation. It's possible to do this. We just don't bother to. We rely instead on fuzzier notions of national responsibility. And of course, what really underpins that is that the negotiation is an expression of a realpolitik, sort of power-based negotiation. Historical legacy of past emissions is also tied up with wealth. You can do the same sort of analysis and show that the wealth in a country is the best correlate of the cumulative emissions in the past. And one of the things that's weird about this is that if you look at the data carefully, if we shifted to wealth from income, countries like India actually do worse off. There are wealthy people disproportionately in poor countries. It actually increases their proportional share. It's not what you would have thought. So take a look at this. We're out of time. But if you think about what factors should determine your individual responsibility to pay for emissions reductions, you could think of it as being your wealth. All of your dollars have robber baron roots. You could think about it as your past emissions, including those embedded in products you bought, your income, your citizenship. When you sign the papers, are you now responsible? And so on. These are lecture teaching goals. Make sure you look at them because I will ask questions, not maybe directly from them, but sometimes. And every question I ask will come from them.